Do you know when we get the first lab back?
Hello and welcome back to Calculus 1, section 3.4, product and quotient rule. Your labs will be back as soon as possible, which is hopefully tomorrow. It was excellent timing, and now we will resume with the product rule. Last time we talked about shortcuts in taking derivatives. We know that we can use the limit with the difference quotient to deal with the derivatives, but then it turns out to be a very painful procedure of calculating limit with all of the tricks of the trade that we have to know. Also not to forget to write the limit on each step. I believe 3 or 4 of you, 3 maybe, students on the exam ignored writing the limit throughout the problem, and then you got to the last step, and the last step was correct, but it was incomplete, and you lost at least 2 points or something like that, because you haven't used h goes to 0 and killed the h term, so you just have 10x as the answer. So at least 3 students, might be 4. So let's not do those anymore, right? Let's have the shortcut now. So last time we said that the derivative of a constant is 0. That was the last class after the test. We also said that the derivative of x to the n is nx to the n minus 1, which covered roots, any root, square root, cube root, fourth root, whatever root, also covered 1 over 6 and 1 over 10, and also covered x to the 5 and x squared and all of those guys, obviously. We also said that the derivative of e to the ax, right, where a could be any number, was ae to the ax. We also said that the derivative of c times a function, you kick the constant outside and you just take the derivative of the function. So all of these rules were there last time, and then the one rule that allows us to find the derivative of each term, if we have multiple terms, is this last rule that I'm writing, which says that you can find the derivative of the first function separately from the derivative of the second function. Now, you are not allowed to do this with a product and a quotient. We have a separate formulas, and that's what we're learning today. So, for addition and subtraction, you just go and you do term-wise, each term on its own, and that's it. But if you have a product, you have to use the product rule formula. So let's write the product rule formula down. So product rule formula says the derivative of f of x times g of x is going to be f of x times the derivative of g plus g of x times the derivative of f. So this is the formula for product rule. So first function would be f of x, and the second function would be g of x, and then you would solve this. Now there's also alternative way to write this, and that is usually people say uv prime, where u is a function f of x and v is a function g of x, and they just say uv prime plus vu prime. If you want to memorize it that way, out here where u is f of x and v is g of x. If this is something that makes you happy, by all means, Remember that. So the derivative of the product, right? So you're supposed to be able to figure out when you have a product of two functions. Let's do some examples so it makes sense. Say you have x squared times x to the 9. Well, you would say, yeah, what's the big deal? I can just make it into x to 11 and use the basic rule. And yes, I hope you will do that, all right? So we know that the answer is 11x to the 10, right? We know that because we can cheat with algebra. You can multiply, get x to the 11, and then take derivative 11x to the 10 and be done. But let's get that 11x to the 10 using the product rule formula to show that the product rule formula actually works. So what do I have? The product rule formula, I don't know which way, the way I learned this is I say copy the first derivative of the second plus copy the second derivative of the first. If that helps, sure. Or maybe you can come up with a song. I don't know. I'm not. Copy the first derivative of the second plus copy the second times derivative of the first. So what do I have here? I have my f g prime g f prime. That's exactly what I have up there. F g prime plus g f prime. Now, the first one is 9x to the 10. The second one is 2x to the 10. And when you add these two, right, 9 apples plus 2 apples is 11 apples, so x to the 11x to the 10. Which is exactly what we have if we check by combining this into x to 11 and then taking the derivative 11x to the 10, same. So we're good. See, derivatives you can't always check. Just hope that everything worked out fine. Integration you will always be able to check. I always liked integration a lot because you suffer for, 5 minutes, 10 minutes, 30 minutes, week, depending on how difficult integral is, and you solve that thing, and then you take the derivative and you check it, and it's wow, right? The derivatives is a little bit different, right? You hope it's good. Until work is back. So let's see another case. Now, here's a good example. It says x cubed times e to the 5x. You see, this is what the product rule is for. Not for the first example. First example you can cheat through algebra, and I hope you would, right? Because that makes the problem easy. You make it into x to 11 and you're done. Right? Now the bottom one you can't really multiply. These guys, one is polynomial, one is exponential. You can't multiply them, you can't add them, you can't do anything, right? So product rule is designed when you have a product of two functions that are not compatible and cannot be combined by algebra. That's why we have the product rule. So now, take the derivative of this, right? So what do? Well, we have x cubed, so copy the first one, times the derivative of the second. Remember that a goes in front, right? So it's 5e to the 5x, plus copy the second, which is e to the 5x, and then times the derivative, which is 3x squared. Now, technically, we are done. This is what section 3.4 is teaching us. Use the product rule to get the derivative, and we did it. Now, the only thing that it's left is algebra factoring. Is it necessary for chapter 3? No. Is it necessary for chapter 4? Yes. So start practicing now. Right? So it's already in your bloodstream when you get to chapter 4, because you know what the chapter 4 is? Chapter 4 is going to take this and then say set equal to 0 and solve the equation. And if it's not factored, good luck. All right? So our job now is to factor these answers as far as we can to have enough practice so it's a second nature when we get to chapter 4. You have to do it in chapter 4. So what can I kick out as a common factor? Well, definitely x squared, right? I can kick out x squared because there are 3 x's in the first one and x squared in the second one, so x squared is common. And also e to the 5x is common to both. And now in parentheses we put the leftovers. From the first parenthesis we have 5x left, right? Because 5 in front of the e, and then one of the x's. On the second one, we just have plus 3. And this is done. Now, in chapter 4, you will set this equal to 0. You will get 0 from the x, no solution from e, and then negative 3/5 from the last term. And those will become critical points, and critical points become minimum or maximum or inflection point, or, there will be things that we'll be doing. This will be just a, margin of things. So, practice while you can. Let's see another problem. So, d dx of 3x to the 6 square root of x. I'll let you enjoy this a little bit before I move in. right? So we have copied the first one, that's 3x to the 6, times derivative of the second. I'm not sure if you started memorizing it or not. You should have 1 over 2 root x to go quick, plus copy the second, root x, times derivative of the first, which is 18x to the 5. Great. Now what, right? So first I'm going to rationalize the first by multiplying top and bottom by root x so that I can combine them into a single, right? So I have 3/2 x to the 6 root x divided by x. The 2 went under the 3. Plus 18x to the 5 root x. Now, x to the 6 and x cancel. And I'm left with 3/2 x to the 5 root x plus 18x to the 5 root x. Hey, who's excited over here? We have the same variable part, right? That means we can add the two. So 3/2, that's 1.5, so this is 19.5, right? If you, 19.5, no, we'll do 39 over 2. X to the 5 root x and be done, right? Good. Did anyone do anything else? No? Or the derivative of 3x to the 6x to the 1/2. Add the exponents to 13/2 and then just use the basic derivative instead of doing anything with the product rule. So the derivative of 3x to the 13/2, and now when 13/2 drops down becomes 39 over 2, x to the 11 over 2. Now, if you want to peel off a half and make this x to the 10 over half plus 1 over half, then 10 over half is 5, and that's this piece, and then 1/2 for the root is this piece. So you can do that. You can end here, or you can go on and say, okay, it's 39 over 2, and then I have x 10 over 2 times x to the 1 over 2, which is 39 over 2, x to the 5 root x, which is the same answer. So we could, we can cheat this way as well. If you can do algebra, why not do algebra, right? How about the derivative of e to the 2x, and in parentheses, 3x squared minus 6x plus 8. Oops, it's supposed to be parentheses. There we go. All right, so we have copy the first, which is e to the 2x, times derivative of the second. Now that's going to be 6x minus 6. What? I think there is like a holy region over here that I can't put sixes in because it works everywhere else. See? I told you. All right, fine. No, it works for everything else. It just doesn't work for sixes. Okay, fine. Plus, copy the second. See? I have to move it over here to get the 6 out of this. There we go. And times 2e to the 2, much better. So now, we have, so if you look at these two, right, the difference in the e to the 2x is the 2, which you should go and multiply inside. So the first is e to the 2x, 6x minus 6. The second one is plus e to the 2x, and then 2 multiplies everything inside, so 6x squared minus 12x plus 16. And now I am going to factor out e to the 2x, and then the parentheses will just add. So I have 6x squared minus 6x, and then plus 16. There we go. We made it. That's what I said. Please pay attention. It's clearly 10. This is 10. 1 and 0. There are 10 different kinds of people out there. Those who understand binary and those who don't. Four people got that. We had to wait for the subway to pass. Yes.
Could you just go over real quick how you got the derivative of 3x squared minus 6x plus 8 real quick? Like how'd you get it to 6x minus 6?
Real quick. So minus 6.
Okay.
Clearly. Yeah. So the derivative of x squared is 2x times 3. The derivative of 6x, x is gone, so it's minus 6. The derivative of a constant is 0. It's a slower version. Wait, were you in that class? No, you weren't. No, it wasn't your class. A student in algebra once asked me to go really slow. To simplify. Let's say you were supposed to add these two polynomials. I literally dragged it out for 15 minutes. Half of the classroom left. They couldn't bear it. We're done with the product rule. No. We're not done with the product rule. Find the equation of the tangent line. Here we go. Find the equation of the tangent line for f of x equals, I think I have to restart this thing. What would be the good, let's see if we can find something something nice that you're not gonna like. There's not really that many choices over here. All right, let's go with x to the 5 e to the x. At x equal to 1. Yeah. Do you know that you take a 9-volt battery and rip it apart? You have 6 of these in there. They don't have this nice shiny advertising on it, and they're just like this. Please don't go home and disassemble the fire alarm to confirm this. I'll tell you it's. I'm telling you this.
I've seen videos of things like that. Where like there's car batteries that just have double A's in them. Oh, she's really stupid.
No, that's not true.
I know it's not.
I'm telling you for a 9-volt battery. Just testing the screen.
You haven't tried to 6 yet?
That's true. I reconnected the pen, so I'm just going to make sure that this was the holy region. Yeah, it works. Got rid of the god. Good. The procedure for tangent line was find the derivative first, plug in the point to find the slope. Use the same point in original equation to find y. At that point you will have x, y, and m. You can find your b. So one more time, find the derivative, plug in 1 to get your slope m. That's the first thing. Second thing, plug 1 in original equation to get y. Then you have x, y, and m. Find b, and you're done. That procedure is always going to stay the same, as I mentioned last time. So the derivative is, copy the first, derivative of the second is the same, plus copy the second, which is e to the x, and the derivative of the first is 5x to the fourth. So that's the derivative. Now, we can simplify this derivative to x to the fourth, e to the x, and then in parentheses I have x plus 5. That works. Now, slope of the tangent line is the derivative computed at the point we are interested in. We are interested at 1. So the slope is always derivative computed at that point. So we are computing slope at 1, which means each x will be replaced by 1. I get 1 to the fourth power times e to the 1 plus 1 plus 5. So 1 to the fourth power is just 1 times e times 6. So the whole thing is just 6e. Slope m is 6e. That's the slope m. Now, I will find y by plugging in 1 in original equation, right? Because original equation is y equal f of x, and x is 1. So I have 1 to the 5, e to the 1, and it's just e. So now I have everything I need. I have the slope, and I have a point which says 1e. That's x and a y. So y equal mx plus b. Y is equal to e. M is 6e. X is 1 plus b. So b is equal to negative 5e. B is equal to negative 5e because you have e minus 6e. So slope of the tangent line is y equals 6e x minus 5e. That's the tangent line at x equals to 1 for the function given. Yeah, you're not used to having e. Just grow up. It's a number. You can punch the decimals in the calculator if that's something that makes you sleep better at night. It shouldn't, but it might. I don't know. So 6e is a number, like 3/2, except it's irrational. So you have 6ex minus 5e. We are going to have this much worse later with pi's and things once we get into trig derivatives. Because guess which problem you're going to have with the trig problem? Find the tangent line, right? And then, yeah. Second half of this lecture is the quotient rule, and it's the same deal. I give you the formula, whole bunch of problems, you will memorize the formula and just grind through, and that's it. Quotient rule. It says the derivative of the quotient of f and g is g of x f prime minus f of x g prime divided by g squared. So that's the quotient rule. In terms of uv, u divided by v prime is vu prime minus uv prime divided by v squared, where u is f of x and v is g of x. Right. Now this one is much easier to deal with. So what do we have? We have x squared minus 3 divided by x plus 6. What's the derivative? Well, the top function is f, the bottom one is g, and just follow the formula. Top function is f, bottom one is g. and just follow the formula and see if you can simplify. All right. Copy g, that's x plus 6, times the derivative of f, which is 2x, minus copy f, 2x, x squared minus 3, times derivative of the denominator is just 1, divided by x plus 6 squared. We will never expand denominator. We always leave it that way, because even when you say equal to 0 in chapter 4, that 0 will just kill it, right, when you cross multiply. So there is no need to ever expand and work with the denominator. Just leave it as is and focus only on working out things on top. So now we have to multiply everything. We have 2x squared plus 12x, and then minus x squared, and then plus 3. Everything divided by x plus 6 squared. And on the top I have x squared plus 12x plus 3 divided by x plus 6 squared. And that will be the end of it. Sometimes you might be able to factor this and cancel. In this case, no, but in some cases you might be able to, so yeah. Let's see other wonderful examples from the textbook. Here are the two cool examples, and then we can move on to the next lecture. So 22 says, find the derivative of 2e to the x minus 1 divided by 2e to the x plus 1. So that would be the first problem to work on. All right, so what do we have? Can it fit here? Let's see. So the way I like to start this problem is I take the denominator and square it immediately, because that's the g squared part in the denominator, and then I copy g as is here, times the derivative of the top, that will be just 2e to the x, minus, copy the top, 2 e to the x minus 1 times the derivative of the bottom, which is 2e to the x. I don't need those parentheses, but whatever. Okay, now if you look at this, oh, this is supposed to be plus over here, the first one, right? Much better. So now you might be tempted to FOIL, but I'd say, isn't it easier to factor? Just factor 2e to the x. And what's left in parentheses is this minus this. And that's just 2. And then you have 2e to the x plus 1 squared in the denominator. So it's 4e to the x divided by 2e to the x plus 1 squared. So instead of foiling and then adding and subtracting, you can actually factor. That's the first out of 2 problems. And the second one, 24, it says, find the derivative of e to the negative x times square root of x. So how do we do this? How do we do this? What do we use to solve the problem? Product. Or quotient. I don't care. How about one half of the classroom use product, the other one use quotient, and you have to...
No.
Should I assign? Okay, which one you don't like?
Both.
I just can't win. Oh, I almost forgot about the clock. Well, maybe try both, since you're sitting there. Try both. You wash this with water. What doesn't wash is a Sharpie. That doesn't wash. Like X, that can't be washed. The rest, right? Like this works fine, and this doesn't work. So you shouldn't be using Sharpie to write in these things. Wow, I'm serious, because it messes things up. Exactly. It's the trick. Oh, exercise. Oh. So I'm hoping you're using product rule first and then quotient. See that both can be used. Actually, yeah, both can be used. All right, so product rule is copy the first, derivative of the second, plus copy the second, times derivative of the first. Now, this is like -1 times x, so you have a, and then e to the negative x there. We can pull e to the negative x common factor, and we are left with 1 over 2 root x minus root x. Now we can rationalize the first to simplify it, because eventually we have to set all of this to 0 and stuff. There we go. It becomes it doesn't help. It becomes root x over 2x minus root x. It doesn't really help. So I guess we can just leave it there. Now let's do the same problem using the quotient rule, because we know that the negative exponents would go in denominator as positive exponents. So now if we use the quotient rule, denominator becomes e to the 2x, and then e to the x times 1 over 2 root x minus root x times e to the x. And what we can do is we can factor out e to the x, and we are left with 1 over 2 root x minus root x divided by e to the 2x.